everyone, welcome back to Yulan's channel. Today we'll be continuing our journey in AP psychology, and today we'll be talking about the principles of perception, and we talk about principles of sensation in our last video. So please check it out if you haven't watched that one because which is a really good video on how we distinguish between perception and sensation. So also this unit is about sensation and perception if you don't know. And if you haven't watched my previous videos on Unit 1, Scientific Foundation of Psychology, or Unit 2, Biological Basis of Behavior, please do watch those videos because having some background knowledge before we start the video is really important and it can help your learning. So yeah, let's begin. What is perception? Organizing and interpreting sensory information is all part of perception. Now, you may ask, what's the main difference between sensation and perception? Sensation is the actual awareness of our environment through the five senses: sight, hearing, smell, touch, and vision. Gust and eat. While perception is the way we interpret this sensory information to tell us something about our environment, making sense of where we are. Perceptual processes. We process information unconsciously as our nervous system work together, each performing part of the task. It's important to understand that perception is majorly influenced by expectations, context, emotions, and motivations. Your perceptual set is your mental predisposition to perceive one thing but not another. Our perceptual set can change what we see, feel, taste, and touch. If someone told you that this new restaurant opened nearby had really delicious food, you'd expect to really enjoy the food, so you go and try it. The smell of the juicy steak as you enter the restaurant, along with your expectation of the food tasting well, might influence your taste and possibly make you think the food tastes better than it really does. So, this example shows the important or how the influence of perception, this predisposition, can influence your actual perception. Our perceptual set is determined by our schemas, which are concepts that organize information in our experiences. Popular examples of schemas are stereotype and social roles. The context effect has to do with top-down processing, which we mentioned in our first video in Unit 3, and this is basically how we percept the information from sense, and the brain going back in time, allowing a later stimulus to determine how we perceive an earlier one. Now, attention is a really interesting topic because everyone, I swear to God, your parents or your teacher will say like, please pay attention to what I'm saying. That's attention is to our surroundings can change with our perception, which is super interesting and you may want to hear this. Selective attention is our focus on the particular stimulus among others. One of the most famous examples of selective attention is cocktail party effect, and this usually occurs in the AP psychology multiple choice section, and this is really common. This is really like high frequency in every single test, every year's exam of AP Psych. So it basically tells us where at a party you can hear one voice among a million others. You're only focused on that person, so all your attention is centered on him, blocking all of the noises. Our lack of attention could also lead to blindness, which is a failure to notice stimuli. The first type is inattentional blindness. This occurs when you fail to see visible objects when your attention is focused elsewhere. To better understand inattentional blindness and possibly experience it, let's use an example. You may have been so focused on the task given to you that you would have never noticed the most obvious stimuli in the midst of all the action. Second type is change blindness, the failure to notice significant changes in our environment. So how this occur on people is by, like, for example, your classmate had a new hairstyle, but you just didn't really notice it because even though you saw your classmate, you recognized his or her face, but like your attention weren't on this classmate, so like apparently or consequently you won't notice that the hair is actually like you percept or like you realize that it is changed. Now we have depth perception. This will occur on every single year's AP psychology exam. So please pay attention to this one. Oh, oops, I said attention here, so look how important it is. So we live in a three-dimensional world. Isn't it wild that our brain can perceive this and judge the distance of objects? This is called depth perception. And cues, which can be monocular and binocular, can guide us when judging distance. Monocular cues is simply saying that cues available with only one eye, like interposition, relative height, relative motion, linear perspective, relative size, light, and shadow. Um, and we'll talk more about that in our video 3.4, which will be about visual perception. So stay updated for that. Okay, let's come back. Um, And the second type is binocular cues, and contrast to monocular, which also indicates by the name, this cues binocular depends on the use of both eyes. There are a lot of examples and how like we have different views of the world. The main binocular cue we really need to know is retinal disparity, which is the difference between the two images from each eye. So imagine viewing a car that it is approaching you. You know that the car isn't getting bigger, but it appears like it is, since it's getting closer to you. This is an example of perceptual constancy, where you perceive moving objects as unchanging. Something really interesting and fun has to do with our perceptual organization, in which our vision always wins when it competes with our other senses, which is there's a term called visual capture. The the McGurk effect is one of the most common examples of visual capture. So even though the sound doesn't change and constantly say Bill, you can hear other things because of what you're seeing. Your eyesight dominates over your hearing, make you hear what you see. So now we have perceived motion. Our brain is able to detect how fast what we see is moving and figure out our own movement of the body. But the cool thing about our brain is that even if we see something that isn't moving, we're still thinking it is moving. This cool effect called the stroboscopic effect is actually what allows us to watch animated movies. Technically, animated movies are made up of hundreds of um, millions of pictures that move at a really high speed. Um, so this makes your brain think that the characters are moving as well. I know. I always thought Mickey Mouse actually moved too. Another phenomenon is phi phenomenon. When you look at the holiday lights, your brain will think it is the one moving. It's moving light if the series of light bulbs are turned on and off at a particular rate. Our brain likes to make up stuff, I guess. The last one is the autokinetic effect. When you stare at a spot of light projected on the wall for a long time, your brain will make you think that the spot of light is actually moving. Crazy, right? Now we have constancy. We mentioned this a little bit some minutes ago. So so this table is from Fiveable, just as you know, and Fiveable is a great website that you can check a lot of AP guide and cheat sheets resources from this great website. So check it out. Everything we see is constantly changing, such as angle vision, variation in lighting, and how we're perceiving things. So how does our brain manage that? Well, our ability to maintain constant perception is called constancy. Constancy. There are multiple types of constancy. The first one we have is size constancy. Objects closer to us are supposed to be bigger, but we take distance into account when making size estimations. Cool, right? If we already know the size of the object, we know it suddenly won't change, so our brain takes that into account. Then we have shape constancy. Objects viewed from different angles have different shape. Our brain, again, takes all of this into account, knowing that an object won't suddenly change shape. And finally, we have brightness constancy. Light reflections constantly change depending on where the light source is at which angle. Our brain, which is smart enough, will know that an object won't suddenly change color. For example, you know that the grass is going to stay green. Even if the sunlight makes it appear as though it's changing color to yellow or orange, something like that. I don't know. Just making things up. Now, culture is a big thing that could influence how you perceive things. The truth is, our beliefs, expectations, and behavior can deeply affect your perception of anything, and culture plays a huge role. So look at this example, this picture on the bottom right corner. People may see like oh my god, the top line is actually shorter than oops than the bottom line, but it's actually the same length. Look at this. It's just the direction of the arrow makes this one look so much bigger than this one. Cross-cultural studies show that some people perceive things differently. For example, if you look at the Mueller-Zeiler illusion in this picture, you might think the second segment of the line looks longer. Those who come from carpentered cultures that don't use right angles and corners when building structure, are usually not fooled by the illusion. This shows that culture plays a huge role in perception. And finally, our last topic of this video is gestalt principles, which we also touched a bit in our last video. So yeah, it could be a recap for some of you. So there are many principles of perception that help explain key ideas of perception. Principle of closure states that we tend to fill in gaps in patterns. Principle of similarity states that similar objects tend to be grouped together. Principle of continuity states that even if an object is intersected, we tend to consider it as one whole uninterrupted object. Principle of proximity, and this is really important, states that close objects tend to be grouped together. Our second last one is principle of good figure. Okay, I made a typo. It's not good fire. It's good figure. States that we tend to see group objects as one whole object. And finally, we have principle of symmetry. State that objects are perceived to be symmetric if the object is formed around its center. So yeah, here comes the end of our video today. So if you're interested, please like and subscribe to my channel. Thank you for listening.